What is refrigeration? Refrigeration contributes to the raising of living standards for the people of all lands. The application of refrigeration principle is limitless. The most common use is the preservation of food. The refrigeration process is a cycling system. Heat is picked up by the boiling refrigerant regardless of the shape of the evaporator. Heat which is rejected at the condenser may be carried away by air, water, the evaporation of water, or other means. Classification of refrigeration systems. In general, refrigerating systems fall according to use into the three groups. 1. High temperature systems, 2. Medium temperature systems, and 3. Low temperature systems. The high temperature refrigeration systems are used for air conditioning equipment where temperatures between 25 to 45 degrees Fahrenheit are needed. Medium temperature systems are used for food storage and other applications requiring temperatures between 25 and 0 degree Fahrenheit. Low temperature systems are for those applications requiring temperatures of 0 degree Fahrenheit or below. Heat energy. The capacity of a refrigeration system is determined by comparing its ability to absorb heat to that of the heat absorbed by the melting of 1 ton of ice in a 24-hour period of time. The refrigeration cycle works in 4 phases: compression, condensation, expansion, evaporation. It is refrigerating unit with open type reciprocating compressor. The machine has following parts: open type reciprocating compressor, electrical motor, condenser water circulating pump, evaporative type condenser, receiver, liquid indicator, hand jet off valve, thermostatic expansion valve, evaporator coil, suction line, accumulator, suction line attached with suction service valve, discharge line attached with discharge service valve. Voltmeter shows the line voltage 220 volt. Ampere meter shows the drawing current of the unit. High pressure, low pressure cutout with cutoff indicator. Water pump switches. Let us start the cycle from compressor. Compressor pumps the high pressure, high temperature vapors through discharge line to the condenser. Here, the refrigerant rejects the extra heat and liquefied. Liquefied high pressure, high temperature refrigerant. High temperature refrigerant liquid passes through thermostatic expansion valve. Thermal bulb of the thermostatic expansion valve is clamped with suction line. Here, the refrigerant liquid changes into low temperature, low pressure state and enters into the evaporator to produce the cooling after boiling at low temperature. Pressure cutout switch cut off the motor circuit cutout. If at any stage the pressure in the system gets lower or increases beyond safety limits, this switch cut off the motor circuit. Practically, it can be seen through an artificial situation. Now, switch off the condenser with circulating pump. The gauge show high discharge pressure after crossing a pre-adjusted limit. The high pressure cutout switch cut off the motor circuit. In the same way, the switch works at the low pressure conditions. This switch works as a safety device. Evaporative condenser uses both air and water as a condensing medium with sprinkle over the condenser coil. A fan installed on the top sucks the air from the bottom side. Air-water mixture absorbs the heat that results in liquefaction of the refrigerant. Water circulating pump regularize the water cycle. Conventional refrigerator. Conventional refrigerators are usually manufactured in different capacities and are normally equipped with hermetically sealed compressor and condenser units. The operation of refrigeration system works on vapor compression cycle system. The conventional refrigerator consists of the components like compressor, condenser, capillary tube, expansion device, evaporator, filter, and temperature control. Frost-free refrigerator. The operation of frost-free refrigerator systems work on vapor compression system. The frost-free refrigerator consists of compressor, condenser, filter, capillary tube, expansion device, evaporator, evaporator motor, defrosting heater, temperature control, and timer. All frost-free refrigerators are provided automatic defrosting with a combination temperature defrost control. Types of deep freezers. There are two types of freezers. One is chest type and another one is upright freezer. Upright freezer. The basic refrigeration system is used on all upright freezers. The only variation being the use of fan-cooled condenser located under the cabinet in a few models. Other upright freezers use a static condenser located on the back of the cabinet. All units are of conventional hermetically sealed design. Chest-type freezer. Ice cream freezers are similar in most respect to chest-type household freezers except for interior design. Refrigeration capacity. In normal practice, refrigeration capacity of equipment described in ton kilocalorie per hour or BTU per hour. In case of refrigerator, refrigerator capacity can also be referred by big volume. Again, volume can be converted in liters. Refrigeration capacity. Removal or absorption of 12,000 BTUs per hour or 3024 kilocalorie per hour is equal to 1 ton of refrigeration. Standard models available in the market. Volumetric capacity. Conventional refrigerators 65 liters, 95 liters, 110 liters, 165 liters, 230 and 360 liters. Frost-free refrigerator 165, 230, 300 and 500 liters. It is a conversion of cubic feet into liters. Identification of refrigerator components. Mechanical parts. Compressor. The function of the compressor is to provide the necessary pumping action to the refrigerant. It draws cool refrigerant in through the suction line from the evaporator. It compresses it and discharges it into the condenser, where it is liquefied. The compressed gas has risen in temperature and pressure at the time of entering condenser. Suction line. The line through which refrigerant from evaporator to the compressor. This is toward the low pressure side of the system. Discharge line. The line between the compressor and the condenser is called discharge line, which is towards the high pressure of the system. Condenser. Condenser works as a door to discard the heat absorbed by the refrigerant at the evaporator, plus the heat added at the time of compression, and the refrigerant gets liquefied. Filters, dryers. To sort out any foreign particle and moisture, not allow entering into the office of metering device. Capillary tube or metering device. It meters out the required amount of refrigerant to pick the heat from the evaporator. It consists of a long, small diameter copper tube as the liquid from the condenser is pushed through a small passageway. The friction between the refrigerant and tube causes pressure drop. Evaporator. Low pressure and low temperature refrigerant enters into the cooling coil to evaporate to produce low temperature and changes into vapors. Electrical parts. Compressor motor, relay ampere type, current type, overload protector, thermostat, cabinet light, door switch.